all the different activities. He has been working very hard. He did his master's from Birla Institute of Technology and PhD from IIT Roorkee. And he worked on a framework for network forensic analysis. So you can understand that he is an expert in the area of forensic, network security, computer networks, and blockchain. He has around 24 years of teaching, research, and administrative experience. And he was awarded ISEA Fellowship by the Department of Information Technology, Government of India. Now it is known as MIT, for his excellent research in information technology. He has supervised several PhD students and currently also supervising around 7 students. He has 90 plus research papers in international journals and conferences of repute. And he is a member of editorial board of Forensic Science International Digital Investigation, which is a publication from Elsevier. He has co-authored 2 research reference books, which is very important for you to note. One is Fundamentals of National Networks Forensic, and the second one is on cloud security. He is a senior member of IEEE and a senior member of ACM, and he is a life member of Computer Society of India. I would also like to tell you that he is a member of Quantum Ecosystem Technology Council of India, and he has been there on various committees, for administrative committees, and above all, I must tell you that he is a member of the core team at Mnit Jaipur for Electronics and ICT Academy. Dr. Pilli, on behalf of all the academies, I sincerely thank you for giving your consent to contribute in this conference, in this program as a speaker, and we invite you to deliver your course of lectures. Thank you so very much, Dr. Pilli.
Thank you, ma'am. Thank you for the warm welcome, and it's a joy to be part of the EICT Academy training programs. And as we also coordinate various programs in MNIT Jaipur, it's a joy to work as a team and also to see the impact, especially a couple of courses recently on quantum computing. There was a great response, machine learning and image processing, computer vision. There was great response. So hopefully this workshop also was very practical, in the sense, first time I think a blockchain course has a lot of practical component where hands-on has been done. Of course, I may not have a lot of hands-on for you, but a lot of work for you to do. That's what I can assure you. I will be introducing a lot of new things, and then you can try to take up. And many times, as we see, blockchain is part of MTech courses on information security. Wherever MTech information security is there, blockchain is placed. The basic reason blockchain is placed is because we think that it is a lot of cryptography, a lot of hashing, and all that is involved, and hence it is a security course. But of course, a lot of things are there which are now currently getting into computer science in that sense. But also, it will be raising a question: is it really? I mean, when there is so much of cryptography, so much of concepts of a lot of algorithms which are involved. Is it really possible to break it? I mean, we are building a secure system. Is it possible? And of course, yesterday I was listening to the lectures, and there were so many questions which were coming up. So let me quickly refresh you and take you through the reasons why security is a question, why people would like to attack, and why would people like to, what are the security and privacy issues in blockchain, and the reasons thereof. And also, while I share this, I would also like to share with you a couple of thoughts that what we should do as an Indian community of researchers, and as
recording in progress.
Forward, right? So, what we should be doing as an Indian community. We are students and faculty members. Many of you are faculty members in various reputed institutes as well. Some of them I've understood that you have a PhD degree as well, and you're guiding research. Some of you are doing your research, and some of you are from other countries also. One of the student has joined from South Africa also, and I'm happy that he's there. So this is a kind of exposure. Yesterday we were listening Shweta from Australia. So it's a kind of a good this thing. But of course, the numbers are dropping as we the day one there were more. But let's look forward to this talk. I would like to share my slides and then continue. So first talk today before the break will be on security and privacy issues on blockchain. But yeah, I have some good news in the sense that I will just briefly review some of the aspects that you have been hearing and some of the questions that are there. So maybe I will take up the questions a little later towards the later part of the lecture. But what I will try to do is I will try to revise some part of the things, because yesterday's questions, as I was looking at, they were mostly addressing or asking questions on the concept. So let me quickly take you through, right? So let's these are some of the words that you know. Anytime you Google up Bitcoin and then you would like to see some of these words are very important. And then of course Bitcoin as or blockchain as we see is the generic name, right? And then now you have Bitcoin, which was related to blockchain initially to start with, and it became quite popular with a security attack, right? In fact, if you remember WannaCry, right? The WannaCry was the attack which led to the popularity of Bitcoin, because people expected money to be paid in Bitcoins. If you remember WannaCry attack, encrypted the systems over the internet. And then you received an email saying that people could identify your email up to that level, and then send you an email saying that if you want the systems to be decrypted, you have to pay so many Bitcoins. So that's where Bitcoins became popular. Then people thought, what is Bitcoins and how it is going on and what is happening, right? So why did they want people to pay in Bitcoins is a question. So one of the main important reason is the payments in Bitcoin cannot be traced, right? So that's something that we tend to look at. And in fact, the first block was created in blockchain. It was called the Genesis block. The first block is said to be the Genesis block, block 0, you could call it, right? So when this block was created, about 50 Bitcoins were gifted. The author himself, in fact, you would have listened to the day one's lecture of Professor Sandeep Shukla. He talked about Satoshi Nakamoto, right? And we don't know whether that person exists or who that person is. But he wrote a paper and he left it, maybe a she also, with all regards to the gender, right? So hopefully that paper became very popular in a couple of days, and he created the first block himself. Of course, he gifted himself Bitcoins. Of course, it was not spent. Till date, they are not spent. You can, if it interests you, you can go and understand why those first 50 Bitcoins that were created as a reward was not being spent, right? So that is something that you can try to look at, right? So then the Times of London newspaper said, Chancellor is bailing out banks. Bitcoin's libertarian roots is what they said. So, in fact, the Chancellor of banks, you have the RBI governor, who is the Chancellor of the bank, and they are bailing out. In fact, what is the thought process here is that banks usually charge a transaction fee, and when people wanted to avoid the transaction fee, right? So that's where this thought process came in. Let's have a ledger. I don't know how many of you remember the ledger, because the blockchain concept is put up in a technology called DLT. It's a distributed ledger technology. Now, what is the distributed ledger? To understand the actual technology, a ledger is like a bank account, right? So I think Professor Sandeep Shukla also mentioned this. So when you go to a bank, of course now you don't go to a bank, you mostly do the banking on the internet. So earlier when we used to, when I was a student, I used to go to the bank and make a transaction. People would... yes,
Professor Pilli, some people are saying not visible, Neeraj and one student Mithai. Can you please tell participants screens are not visible, I'm getting. Can you please unshare, because I can see the...
Okay, I'll reshare, ma'am.
Okay, so my student told that you have no longer, you're no longer co-host.
Yeah, I think. I'm just trying to share. I'm not able to share now.
No, just a minute. Yeah. I was able to see, but not everybody was able to see. Now I'm making you co-host. I have already made you co-host now. Can you just see if everything is fine? Fine. So there's a lot of uncertainty in these, online things.
Yes.
Now visible. Thank you, Ajitji. Thank you, everybody. Yeah, thank you, everybody, for telling this. Yeah, we can start.
Oh, sure. Sorry. Of course, the flow was going on. Anyway, let's continue. So the point that is there is why blockchain has come into the picture is to make everything a public ledger, right? That's where the distributed ledger technology. That's what is the technical term for a blockchain, right? So we have a public ledger which is open. It is like you'll be surprised to know if you have a bank account and everybody can see all the transactions, right? That's what blockchain is. Oh my God, you will feel very bad, right? So, but the point that we are trying to look at is 1 minute. Sorry. The point that we would like to look at is that anybody can see all your transactions, whom you are sending money, whom you are receiving money from. That would be a public ledger. Then you will not be happy. Why should people see? But if somebody told you, nobody knows who you are, right? Nobody knows whose bank account it is. Nobody knows. But all the bank accounts are open, but nobody knows whose bank account it is. Then you have no problem, right? Okay, go ahead, right? So basically, as we look at it, blockchain is something like this. All the transactions that you're making is public and everybody can see. Maybe people can also guess how much money you have or how much money is there over a period of time. That's what I'm trying to look at. Why am I trying to give this introduction? I'm trying to give this introduction because if we don't understand these things, then we will not be able to really understand security aspect. So let me take you through this. So this is what the basic idea why Bitcoin was created. Two things. One thing is we don't want to pay any transaction to the bank. That was the point. Second point was we don't want any of the transactions to be identified. Now, one of the great things that the present government has done for us is all electronic transactions. They have encouraged a lot, right? I've got Paytm, Google Pay, and UPI, and so many things. And all banks transactions are there. And then when, of course, I don't know how many of you are paying tax. Students may not be paying tax, but faculty, most of you may be paying tax. Then you have to declare your bank account number. So at the end of the day, all the transactions that you do are logged. So you cannot, I mean, you are accountable for all of them. So anybody who doesn't want to be accountable wants to look at some of these things. But so these are 2 points. First point is I don't want to pay any transaction fees. Second point is I don't want anybody to know my transactions. The kind of you can say hawala if you have heard that word, or black money otherwise. But then there is a lot of reputation also that is involved with the blockchain. It is not that negative because it can be used as a stock also. I was discussing some of these thoughts with my students, and they are more aware. They are doing transactions and they are doing how the sales of the Bitcoin is going on. I will share some of those thoughts as well. So the first point is now not more valid because earlier transaction fee was not there. You can send money, you can receive money, no problem. Money in the sense cryptocurrency or bitcoins. You can send bitcoins, you can receive bitcoins, no problem. No transaction fee. But now, as we realized that more and more bitcoins are generated, only few bitcoins have to be identified. So once after all the bitcoins are identified, there's not going to be any more rewards because the halving, as somebody would have explained to you, I will also show you the table. But then after some time, there will be no rewards. When there is no reward, what will be the motivation for miners? What will be the motivation for blocks to be added? It will be the transaction fee. And some of those concepts become very important because if the transaction fee is more, I will include those transactions into my block. Now there will be miners who will become very selfish as well. So these are some thoughts which will attack. But beautiful concepts that you have learned till now is amazing thought. Who is behind this blockchain? Nobody knows, or Ethereum, or there may be some companies which are doing this permissioned blockchains, but the public blockchains which have been created, wonderful computer science going behind that, wonderful algorithms, wonderful crypto that's going behind that. And I think one of the reasons why the government has called blockchain or Bitcoin or Ethereum a legal tender. They have not called it illegal as well, so don't worry about it. You can still buy and sell digital coins, crypto coins, no problem. Cryptocurrency, you can deal with cryptocurrency. You can consider it as a what you call as a as a stock, I would call it, because the rates are increasing. I will just share with you some of those thoughts. So the interest is huge because the money is heavily involved. So now maybe from an Indian perspective, we are more interested in the commercial value of the bitcoins as we look at it, but then we should also look at these things. Some of these points is basically Bitcoin is solving an encryption formula. I will shortly share with it, but then it requires huge amounts of power. So that's the catch here. You get a lot of money because when you solve a Bitcoin problem, you get some Bitcoins as a reward, and those Bitcoins are huge in cost. So that money you can convert it into US dollars, Indian rupees, or any of those things, and then you can use it for something else. So maybe if you look at it, about 6 Bitcoins are given, more than 6 Bitcoins are given. Today, if you add a block, 6 Bitcoins is roughly now, earlier, maybe in November, it was like 60 lakh rupees. So 6 Bitcoins is like 3.5 crore, I think. So that's huge amount of money, right? Now today, I think it's about 40 lakhs. I will tell you what is the current price shortly in the slides that are coming, right? So, and then Bitcoins can be split up into multiple ratios of that, right? But if you want to buy a Bitcoin, or if you want to get a Bitcoin, how do you get it? You can go to a Bitcoin exchange, like a stock exchange. If you want to buy stocks, you go to you have a Demat account and go and buy it. Otherwise, if you want to buy a Bitcoin, you create an account. Maybe one of the popular exchanges called Binance. I will show some slides on Binance. So in the next talk after the break. So there you have some of these Bitcoin exchanges. You can go and pay Indian rupees or dollars or whatever using a credit card, debit card, whatever, and you can buy some crypto coins, right? Bitcoins. You can buy from anywhere. Right? You can have an exchange. It's like your Paytm wallet or Google Pay wallet. Of course, there you deal with only rupees. But Binance or some of these exchanges, they deal with a variety of Bitcoins, and you can sell it and buy and all that, right? If you have a friend, he can transfer it to you. If he has some Bitcoins or any of the other coins that are there, you can transfer it. Or you can become a miner. You can mine a block, right? The mining of a block, of course, the only requirement, as I told you, it requires huge amounts of power. And that is, huge hash rate that is required. The Bitcoin current hash rate is 114 million terahashes per second. So that's huge requirement that you need. So these are 3 options how you can go ahead, right? So presently the terahashes, the hash rate has come down because China has banned the mining, right? Because huge power is getting consumed, and then the country's resources are getting depleted, right? As of now, I don't know whether there are so many miners in India, but then yes, there may be few companies who may be involved, and then they are paying huge electricity bills, but they are doing this this network, right? So this is what I was talking about, halving of Bitcoin. So earlier it was 50 Bitcoins. 4 years later, in 2012, it became 25 Bitcoins. Then another 4 years later, it became 12.5 Bitcoins. Last May, during the pandemic time, it became 6.25. Maybe another 4 years, 2024, sometime early 2024, February, right? So if you look at a statement, you can go to any of those explorers, right? There are the entire blockchain can be viewed. As I told you, it's a public ledger. Anybody can view that ledger. So these are some websites where you can go and look at those ledgers, and you will see the latest block that is getting added, a number of transactions that are getting included in that, who is creating that block. The names of the blocks usually in pools they are coming, because earlier it was a single miner who was doing the job. Now single miner's resource is not sufficient, so I have to combine multiple resources and then add it. Of course, size of the block, because all the transactions and everything, and then the time at which it was included, of course, the reward and the transactions that are there. So the transaction amount and everything is added, and the time at which the block is added is there. So yesterday evening, I took out this slide. So the latest Bitcoin, presently it is 717,475. This was like in 2020, August 31, right? August 31st, there were 646,148 was the number of blocks that are added. I'm talking about the Bitcoin blockchain, standard blockchain or the traditional blockchain that we would call the first blockchain that we would call the Bitcoin. Now it is 717,475 yesterday night, right? Of course, I also wanted to take it just now, but then you can also understand that it takes certain minutes for a coin to be added. Usually it is 10 minutes is what is trying to be created, right? 1 minute. Just give me a second.
Recording stopped.
Subject plus A plus number plus V3 the
Recording stopped.
Is going on, right? So roughly it should be added in 10 minutes. So there is a difficulty level of a block to be added. That is surprising and excellent, right? So just imagine if some blocks are created fast, like in 5 minutes time. As you see, this is 1 minute gap. Some blocks are created in 1 minute block. Some blocks are created. So obviously there will be some gap in between, right? After some time, it takes like usually it take 10 minutes, but then the competition is so fierce that people are trying to create more blocks. But then the Bitcoin blockchain adjusts itself over a period of time. So in a day, only a certain number of blocks get created, right? So usually the time is 10 minutes. So how is that controlled? Somebody else is controlling. I don't know. It has been programmed into it, right? So the difficulty level changes and automatically it adjusts it so that some blocks are created fast and some blocks are created slow. Maybe in the previous slide, let's see if that is there. As you see the time here, 47, 36, this is 11, then this is 12, and this is 11. So usually, and then as you see here after 8, it was like, sorry, not that, 43 and 49 is 6, and this is also 6. So like that usually, and there is a gap here. If you see 7 and 28, there is a 21 minutes gap here. So difficulty level is increased. So these are some things that we try to understand. But what is actually needs to be done in this diagram I will show you. This is one block. What is needed is what we need to calculate the next block hash address we don't know anyway. This is not a concern. But the previous block hash address we know. This is what is found out by the miner. So the previous block hash is already there. So you take Merkle root. Of course, this was explained by Professor Sandeep Shukla. So transactions are arranged. All the transactions that are coming, they are arranged, and then you get a Merkle tree, and the root of the Merkle tree and the hash of the root is called the Merkle root, right? So you have a tree, you have a hash which is created, and the root hash is said to be the Merkle root, right? So you have the Merkle root, and then you have what is called what has to be mined. If the mining algorithm involves, you have to find out the nonce. So now, when all the attacks that I am going to talk now are going to play on this aspect of mining, right? So because this is what I want to play with, this is what I want to do it fast. To mess with is what you can try to understand. The other aspect is a block gets finalized when it receives a certain number of confirmations. Let us say at least 7 confirmations it has to receive. Then the block is added in the next block. So if 2 blocks are added of the same type and 1 block receives more confirmations, this block gets done. And then this chain continues. So it's very tricky in that sense. So there are so many jugaads that come into the picture, right? Our Indian mind talks about that, and then people try to see how best I can do it, how fast I can do it. Can I create more blocks faster? That's one thought. How can I use more better hardware? Yesterday somebody was asking, if I use a powerful computer, yes, we are coming to that also, and we will look at those kind of attacks. So please try to understand what is needed for a block to be added: the previous block hash, the Merkle root, and the nonce value. The nonce value is to be guessed. The nonce value is to be guessed so that the present block hash you can get. So this has to be calculated. What is the input? Merkle root, previous block hash, and the nonce. These three values are to be considered, and then you have to calculate a new block. Once you get a new block hash, it's the same here, and this value is the same. You have to create this block, and this block will have sometimes 18, 19, 20 preceding zeros depending on the difficulty of the block mining. This has to be created. Now, if this is created, the block can be added. Once the block is added by a miner, the first miner who does it, he says, "I am correct. I have solved the puzzle, and I am adding it." So then their other miners also reach that point, but by that time the block has already been added. And they don't fight with him, or they don't argue with him. There is no mechanism to argue. I was first, or you were first, or whatever, right? There is no argument. If somebody has already announced that block and it is displayed across, and immediately the others will see it, and then before they go to the next block to be mined, they'll say yes. Like that, if 7 or 8 people say yes, then the block is said to be confirmed. The block is said to be added. So there are some, multiple blockchains keep running, but then only one continues ahead, because as it receives more and more confirmations, the other blocks get dropped, and then as you take it further. So based on this concept, also there are some attacks, right? So if you can get some of your friends who are miners to say that your block is the right one, and give more ticks, more confirmations at the earliest, then you may have an edge. So these are some concepts that are happening, and just imagine the thought at which people are moving. At one point of time, when I try to look at, because my interest is security and forensics, to every aspect. So for cloud, I started with network security, network forensics, cloud security, cloud forensics, big data security, big data forensics, IoT, trust management, security, now IoT forensics, and then moving on to blockchain security, and then maybe blockchain forensics. Already one paper has come on blockchain forensics. People are thinking how to do forensic analysis on blockchain. Just imagine the kind of problems that are there, the kind of people, how much people are thinking. A couple of years ago, when I made a presentation on blockchain security, people laughed, and they were more intelligent people than me, and very well versed in the sense. But they said, what you're thinking is not going to really happen. But unfortunately, or fortunately for me, a couple of years later, that has been a reality. And as we see, blockchain security is very much in place, and then you see a lot of literature, a lot of papers coming up, and then you can also attempt it. Some of these things are possible to be shown. So by this background, let me take you forward, because these you have already, people have shown you, you have also listened, but I just wanted to clarify, because whatever I am going to place before you is based on these thoughts. So as we look at it, these are the transactions that are happening. So you have some addresses which are coming, and some amount of bitcoins that are there, and you are pooling all of these. So mostly when some of these things are coming like this, you tend to realize that they are all mostly may belong to the same address, right? So usually the public address is what is displayed, and whenever it's like your email address, and you can tell it to some people, and then you can create a QR code of it and share that QR code to others, and then they will scan it, and then they can use the public address, because nobody will be able to remember this 35-bit public address, right? And then you have your own private address, or the private key that you call it, and then you can open it. So people, by looking at your public address, they will send you the thing, and then by your private key, you can verify it, claim it, and you can use it somewhere else. So that's something that is understood, right? So these are some things like earlier 10,000 bitcoins were used to buy a pizza. Maybe now you will get 10,000 pizzas, more than 10,000 pizzas for a not even a single Bitcoin, even a milli Bitcoin will get you that, right? So that's the kind of ratio. It was like a stock. Earlier it was very low, almost like a zero. People say that 50 Bitcoins Satoshi Nakamoto did not sell, because at that time it was practically zero. You have to gift out Bitcoins free. So he said, let's keep it, right? So those are still there and they are still unused, right? So they have never been used in any transactions, right? So the other use of this blockchain, the cryptocurrencies, is basically on, as we look at it, on the negative aspects. Maybe you want to buy some drugs. There was something called a Silk Road, right? Silk Road was a popular road in history a couple of years ago, where East and West were connected, and then that was a route through which all of these things were sent. The precious Eastern countries' resources, spices or silk or something, they were sent to the Western countries, right? And then huge resources from there in terms of money or gold or whatever was sent back to the Eastern countries. So the Silk Road was a very much, but then there's an online Silk Road which was created where you could buy some of these things like pornography or maybe fireworks or guns and ammunition, all the stuff that an underground world would the world dawn world would need, right? So this was what was the thing. So maybe if you look at it, 2013 the FBI shut down the Silk Road, and in fact if you read some of the important attacks that are happening on blockchain and how FBI and some of these government investigative agencies are closing, you will be very excited to hear that, right? And maybe you can watch some of these movies also where these concepts are shown and how the government acts and how these problems are solved, right? So why are security attacks happening on bitcoins or blockchains or some of these things? Is because money is increasing, right? 2020 it was 13 lakh, and August 2021 it is something like that. December it was 19 lakhs, right? December 2020, right? 19 lakhs. Few years, in the last few years, you see there was a interest, and suddenly the Bitcoin rate increased, but again it came down and went on, and slowly as you look at it now in 2021, this is where it's available on CoinDesk. You can go to this website and you can look at that. There was a point when it was 60 lakhs. This was sometime in 14th April 2021, right? So this was 16 lakhs, 63 lakhs. And now, recently, in 10th November, it crossed somewhere around 67 lakhs, right? 66 lakh 935. So that's the kind of 93,589 rupees. That was one Bitcoin, 66 lakhs. Suppose now it has again come down, and roughly it is this thing. So you can see the huge amount that is involved. Maybe something like 70 lakhs someday. One Bitcoin is 70 lakhs, and if you mine a block, you're going to get 4.2 crore of rupees. So that's huge amount, right? And that's where the interest is. Now, if somebody can actually cause a havoc or cause a faster way of earning things, so why not? So that's where the attacks come in, right? So the PayPal and Tesla, BlackRock, JP Morgan, most of these are using PayPal. Is going to allow, it's going to be a legal tender. Bitcoin is going to be a legal tender. You can buy and sell using Bitcoins, and there are so many exchanges. Very easy to make these transactions. Only thing is you need to do your KYC. That's what. So some of the recently government also is very keen on understanding, or it wants to control the blockchain, because if people convert the money into blockchain, and when the blockchain cryptocurrency cannot be tracked, they cannot find out what's going on. So they are going to loop in all the exchanges, and they're going to rein them. So all the exchanges have a very strong requirement of KYC. So who is making all the transactions can be easily known by the government. But then, if you don't want to go to an exchange, you can directly do your own transactions, and you can manage it, and nobody will know about it, right? So that is something. So exchanges we go because it's easy for us, and we rely on the exchange. So suddenly, if someday the exchange closes and he says, sorry, we got lost and we lost your money, it is something like what some of the nationalized banks have done in the past, where they have the privatized banks have closed, and they said we can't give the investors the money. Now, a lot of banks, you may remember, a lot of investors lost their money. Hard-earned money was placed in the banks as FDs and this thing, and they're lost. So something like that. So there is no centralized agency. Now, if you 1,000 rupee note, if you hold today, it is very risky, because it is demonetized, and hence it is not a legal tender. In that sense, it is an illegal tender. But you can have a 2,000 rupee note and a 500 rupee note. It's a legal tender. So as of now, Bitcoin is not legal and Bitcoin is not illegal. But the moment government may declare for those who don't have, who don't disclose that they are dealing with the Bitcoins, they will have to pay a severe one. So there is a slight uncertainty in Indian context. And of course, there are a variety of Bitcoins that have been created, and these are some of the rates. And the rates are varying, but the market cap is more. So Bitcoin is, of course, this is a couple of days old, right? So you can go to that, the blockchain, blockexplorer.com, and then you can see the latest rates, what's happening. And then you can open a wallet in Binance. I will share that later. So, or you can open a Block Explorer also. You can open a wallet, and all the blockchains rates are readily available there. And then you can just make transactions in between. In the next class, I will deal with, right? So, why I already discussed this, right? It is purely a cryptocurrency. You don't have to carry it. First advantage. It is not controlled by a central entity. It's a disadvantage and it's an advantage. Those who want to deal with money which doesn't want to be accounted, right? It's an advantage that nobody is going to observe. But if somebody loses money, then nobody, if your note, 2,000 rupee note gets torn, right, into some part of it, and then you can go to the RBI outlet, or most of the banks take it, and if the banks say it's very bad, we don't want to go to the RBI, they look at the note, and then they give that, they take that note and give you a new note. There's a central agency which is taking care of it. But in case of Bitcoin, that option is not there, and then you may have to this thing. So you are not controlled by any central entity. It also solves the double spending issue. I think yesterday we had discussed, Professor Sandeep Shukla had discussed on, but that is one of the attacks that I will start with, right, to understand, right? So this is what happens. The basic why blockchain is used otherwise, apart from cryptocurrency, the advantage is it is because it is immutable, right? And there is immutable means any thing that you record on it cannot be changed. It is like your DigiLocker kind of thing, right? Maybe you have most of your public documents which are there, and they can be verified, right? So when a police person asks you for a license, you can show it on your DigiLocker. When you want a 10th class mark sheet or something, you can show it on DigiLocker if you have uploaded it, and people will accept it as valid, right? So because you can't change anything which are there already in that, right? So these are some things which people are missing. So entire copy of the history of transactions is available. So these create a requirement for privacy, right? Just imagine entire data, all the blocks, now 7,17,000 odd blocks are created. All the blocks, all the transactions in the blocks are available as a big database. Now in this data, now, as you know, a lot of machine learning algorithms and data science algorithms, a lot of statistical techniques, you can apply on them, and you can find out some relationship. You will not know who the individual is. Now, just imagine, it is privacy is something like this, right? Privacy is something like this, that security or confidentiality, if you look at it, it is something like this, that two government heads are speaking. Maybe, let us say, what you call Biden and Narendra Modi ji are both talking to each other, right? Mr. Biden is calling Narendra Modi ji, and somebody gets the telephonic conversation or an email which is sent by Indian government to US government. Somebody gets a copy of that email, right? And then that's a big issue. That is a security issue. That's a confidentiality issue. Somebody has gone into that. But just imagine somebody knows that Modi ji had called Mr. Biden. That is also news. That also should not be known, because people can guess what did he talk, what was happening, what are the major national events or international events that are going on, what are the issues with the neighbors, and suddenly when Modi ji had made a call, what does it mean, right? So that is a privacy issue. So in that case, when this whole ledger is publicly available to you, right? And then how are these ledgers all the transactions coming, they're coming from somewhere, right? In fact, this whole ledger is maintained somewhere, and all the miners and all the people who are doing transactions are connected to the blockchain somewhere. Now, how do you create a blockchain? Maybe you have discussed with Hyperledger, you have set up Ethereum, some of those examples were discussed for you. So when we set up here the Bitcoin core, we downloaded the Bitcoin, the blockchain software, and then we installed one node, and then you connect it. So obviously what happens, there is a network connection between blockchain and your node, right? So there is a kind of some information which can get served. Of course, we don't know. If you are intelligent only, then we'll be able to understand. So these are some informations that are there. The entire transaction data is there. All the nodes that are connecting, their information will be there somewhere. And then all the transactions data is timestamped. And the basic use is that you cannot change it. So these are some aspects that we look at. And I'm skipping some part of it because you already discussed all of these. These are. I will suggest you to visit this andersbrownworth.com/blockchain, a simple emulation program, right? To understand a simple how blockchain works, right? And how what is meant by Coinbase. Some of the words are basically introduced. So I am just skipping that part. So now you try to understand the hash of the transaction is mentioned here, right? And the address is mentioned, which is the public that belongs to you. Whenever you download a node and set up your network connection, you are given a public address and a private key and a public address. So the private key you keep it with you. That is used to verify the transactions, but the public key is there where to transfer money to you or transfer bitcoins to you, you need to tell him your public address. This public address can be represented as a QR code. You can send that QR code to your friend. Your friend can scan that QR code, get the address, put that address into that field, and then he can send it, right? So that is what it is. This is public addresses of friends who are receiving. These are your friend's address and this is your address, something like that. So he can split one coin into multiple transactions. All these possibilities are made, and then there is a transaction fee that is charged on this, and they get added, right? So now people when they are picking up transactions to add to a block, people are picking up bigger transaction money. So they are all lying there. So many transactions are lying there. How do I pick the transactions? I can choose some of the transactions which are big. So some transactions which are having low transaction fee are getting left out. It is like your what do you say, the problem, the smallest job, they get delayed, right? The bigger jobs, they get preference and they move on. There is a starvation in the operating system as you study. So similar things will happen. So these are some of the attacks that are there. So when you want, maybe you are making a small transaction, but you are wanting that this transaction should come forth. So then you should announce a higher transaction fee. So these are all important. Now there's a kind of a estimation that you have to do. How much transaction fee should I pay so that my transaction will be completed immediately? Otherwise, the transaction will not be done and it will be lying there only on the the databases that are there. I will discuss those databases that are there. So this is the amount that is transferred, and then these are the transaction fee, and this is how a kind of one transaction looks like, right? So as I was talking, there are two databases that are there that are maintained. One is called the unspent transaction output. It is said to be UTXO, right? So in a Bitcoin transaction, each input spends the Bitcoins paid to a previous output. So you try to maintain the main parts of the transaction, and there is a transaction 1, transaction 0. So the input spends a previous output. So this is called a UTXO, unspent transaction output. So they are maintained in that, right? So that is there. So when a user wants to spend bitcoins, you can create a transaction. You can send it to all the peers. You announce that, right? You are having a, let us say you are not dealing with a public exchange, right? You want to do it private. So you have a Bitcoin core setup, node is set up. From the node, you make a transaction, you announce it to all peers. It goes to everybody. Everybody receives the transaction. And the transaction is stored in what is called a mempool. I will discuss that shortly. So mempool, now many people come and then they pick up them and they become the UTXO, they put it in that, and then they will try to create a block. All those transactions, they create the hash of those transactions, create the Merkle tree, create the Merkle root, then look at the previous hash, find a nonce value and get the new hash. And once the new hash satisfies the target value, then block is added, right? And the block is confirmed by others, and then finally the transactions are complete. So all those transactions are removed from the mempool, right? Then the transaction is broadcasted to the entire P2P, and then now you and your friend can be, or you and the vendor can be very happy that the transaction is completed. So these two databases, UTXO, it contains all the spendable outputs that are available to be spent in a transaction. That is one. Mempool is a file that contains transactions which are received by peer nodes but are yet to be included in any block. So they are the unconfirmed transactions. So these are two databases which are maintained. So all along this entire block are added, this data is readily available, right? So all the transactions, all the public addresses, though I don't know to whom the public address belongs, but I know that this public address is made this public address. And using data science techniques, using machine learning techniques, some of these, the entire blockchain can be traversed, and you can build a process in which this one public address you can take and scan through the whole blockchain and see how many transactions he has done, how much money he has, what is his current balance, what are the frequency with which he makes a transactions, how many transactions he has made, how many addresses he has sent money to, who all have sent money to him, this kind of, we don't know who the individuals are, but we know the entire history. But then from there, if you slowly dig in to his geographical address, his this thing, somewhere down the line, right, you can try to create a relationship, right, between, and sometimes some of the public addresses are belonging to the vendors, and those that this person is maybe that it's a Netflix account or something like that, and then that this money is going here, so he is spending money here. So that kind of a thing comes up, and slowly you can try to get as much possible the privacy information as possible. So anyway, of course, you don't actually get to the individual, but then yes, you can get as close as possible, and there can be some related information that is there. So the blockchain is a chain of blocks that are created like this. So this we have discussed. You can't change it because the previous hash are linked. And then if I want to make one transaction change somewhere, there's a big avalanche effect that comes, right? There's an avalanche effect because of the Merkle root concept that is there. So the Merkle root hash is something like this. So you have different transactions here. These transactions, you get these hash values, and then you combine those hash values and so on, and finally you create the root. So this becomes the Merkle root, right? The hash of all the transaction data till here, it becomes the Merkle root. So that's how it is, right? So the proof of work, the consensus algorithms that would have been discussed, the proof of work algorithm is basically you have to calculate the value called nonce, right? So this is the demonstration that I was talking about. You can visit this site andesworthbrown.com and then you can view that. The entire just a hands-on kind of this thing you can look at that, right? Now the first kind of attack that we can look at is if you want to change the values, there's going to be a big avalanche effect, right? You can change some nodes, but you cannot change all the nodes, right? It's very difficult because every vendor has a copy of the blockchain, right? So it's very difficult to alter or tamper this information. So the avalanche effect is there. So a slight change can cause a predicted output. Because why? Because if you change data in one transaction, it results in the change in the hash of the transaction, right? The Merkle root is created by the hash. So it results in the change in the hash of the block, because Merkle root will influence the hash of the block. This hash of the block will influence the hash of the next block, obviously, because if I want to find the new hash, I depend on the previous hash, and the previous hash is dependent on the Merkle root, and the Merkle root is dependent on the hash of the transaction. So if I make one transaction, the hash of the transaction which influences the Merkle root is changed. If the Merkle root is changed, the hash of the transaction is changed. If the hash of the transaction is changed, the hash of the next transaction is also changed. So this cycle continues and you get what is called this thing. So This is not possible. That's what they say. That is what is immutability. Hence, why people believe or why people want to use blockchain in variety of issues. Right? Some of you are talking about healthcare. Some of you are talking about systems. Some of you are talking about education, where certificates can be kept secret, or any information which should not be changed. Maybe one of the good example is building records, right? So a lot of problems happen in the registrar's office, right? A lot of times we go to the registrar office, you have to give a big bribe and all, and then to get the document that this land belongs to you is very difficult, because land is something which is, you can't mark it and do it, all of these things. But then you can create a mechanism in a blockchain that if the land records are all digitized onto a blockchain, nobody can change. And when nobody can change it, it becomes very difficult. So you can avoid a lot of corruption issues when you want to go into this. But as yesterday Dr. Shweta was also mentioning, any application that you want to develop on blockchain, right, you need to understand that there is an overhead. What is the overhead? You want to store some data and retrieve some data. You may think it's very easy. For a concept to think of that I store the data in Google Drive and retrieve the data, there's no cost that is involved, maybe very less cost that is involved. If the data runs into a few GBs, then Google may start charging you for that, right? Or Azure or any of these cloud service providers which give you storage may charge you for that. But otherwise, it's basically free. But here, any transaction you need to do, you want to store some information as a transaction, you don't only have to